Welcome in Engineering Materials and Metallurgy. Today we will discuss about the types of the cast iron. So the one of the important type of the cast iron is the gray cast iron. So in gray cast iron, the graphite flakes present in the matrix of the pearlite, ferrite and martensite. So gray cast iron has a wide range of the applications. It has a low ductility and elongation is 0.6%. Gray cast iron forms when there will be a slow cooling, as in heavy sections, and if it has a high silicon or carbon and slow cooling process during the manufacturing or casting, the gray cast iron is formed. Typical properties of gray cast iron are: it depends strongly on casting shape and thickness. Then, according to AS 1830 and ASTM A48, specific properties of gray cast iron are as follows. So it has a low strength for the A48 class 20. RM is 120 megapascal. High percentage of carbon present, so that is from 3.6% to 3.8%. Then hypoelectric process will be occurred and pitch graphite is available. Then it has a high conductivity and high damping capacity. For low strength class 20 A48 type of gray cast iron. Next, for high strength A48 class 60, RM is 410 megapascal. So RM is the tensile strength of the material. Then it contains the low carbon and it has a eutectic composition. Then graphite form in the gray cast iron. So here in this diagram you can observe the flake form. This black portion present in the flake form is nothing but a graphite. So it is a presence in the uniform manner, or it is also rosette type. Then it is a kish type and normal type. Then there will be interdendritic randomly availability of the graphite, and preferred orientation is also there for the graphite. Then general properties of the gray cast iron are as follows. Machinability is excellent. It has a low ductility, 0.6%. Then impact resistance is also low, but it has a damping capacity high. Then high thermal conductivity, and dry and normal wear properties are excellent. The applications of gray cast iron are for the engine parts like cylinder blocks and liners, then brake drums, clutch plates, then pressure pipe fittings, which is AS2544, then machinery beds like lathe machine beds, then furnace parts, then glass molds, etc. are the applications of the gray cast iron. Next is a ductile cast iron. It is also called as a nodular cast iron. So it is a inculation with the Ce or magnesium or both causes the graphite to form as a spheroids rather than the flakes. So it is also called as a spheroidal graphite Sg, and it is also known as a nodular graphite iron. So for better ductility than the gray cast iron, that's why this type of cast iron is called as a ductile cast iron. Then microstructure of the ductile cast iron or nodular cast iron or spheroidal graphite cast iron. The graphite sphere surrounded by the ferrite. So this black portion present in the figure or microstructure in spherical form. These black dots or spherical form of the diagram is called as a graphite nodules, which is surrounded by this white portion. So this white portion is called as a ferrite, and the remaining portion is some amount of pearlite is there. Then some part is cementite. So it can be hardened to martensite by heat treatment. So if we provide the heat treatment to this ductile cast iron, it will get converted into the martensite. So this structure goes to change into the needle shape structure. So that will be called as a martensite after heat treatment. So the ductile cast iron can be hardened by heat treatment so that the ferrite or the graphite will be replaced by the martensite. Then the properties of ductile cast iron, the strength is higher than the gray cast iron. Then ductility up to 6% as cast or 20% annealed. Then cost is low. Simple manufacturing process makes the complex shapes. Machinability is better than the steel. So these are the properties of the ductile cast iron. Then applications of the ductile cast iron in automotive industry, 55% of ductile cast irons in USA for crankshaft, front wheel spindle support, steering knuckles, disc brake calipers, etc. Then pipes and pipe fittings joined by welding for AS2280, the applications of ductile cast iron. Next is a malleable cast iron. So here graphite in nodular form. Malleable cast iron is produced by heat treatment of white cast iron. Graphite nodules are irregular clusters. Then it has a similar properties to that of a ductile cast iron. This is the microstructure of malleable cast iron. So here there will be the uniformly dispersed graphite. In black spots are the graphite. Then ferrite, pearlite, and tapered martensite matrix is also there. So this polygonal equivalent structure is a ferrite. Some amount of pearlite and martensite is also there. Then ferritic casting required 2-stage annealing, and pearlitic casting required 1-stage annealing. Then properties of malleable cast iron are similar to ductile cast iron. Rather than that, or other properties are good shock resistance, that is damping capacity, good ductility, good machinability. Then the applications of malleable cast iron. So the similar applications to that of ductile cast iron. Then malleable cast iron is better for the thinner casting. Ductile iron better for the thicker casting, which is greater than the 40 mm thickness. Then applications for the manufacturing of the vehicle components like powertrains, frames, suspension and wheels. Then another applications are steering components, transmission and differential parts, connecting rods, etc. Then railway components can also be manufactured by using the malleable cast iron. Then alloy cast irons, whenever the alloying elements are added into the iron or cast iron, the alloy cast irons are formed. So the alloying elements are chromium, manganese, silicon, nickel, aluminum. The range of the microstructure increases. Then beneficial effect on the many properties like high temperature oxidation resistance, high corrosion resistance in acidic environment, then high wear and abrasion resistance. Then alloy cast iron, they are graphite free and graphite bearing. General properties of and applications of ferrous alloys. So the ferrous alloys are useful metals in the terms of mechanical, physical, and chemical properties. Alloys contains iron as the base metal. Carbon steels are least expensive of all the metals, while stainless steel is costlier. carbon and alloy steels. So it has a high strength, low alloy steel. So it has improved strength to weight ratio used in the automobile bodies to reduce the weight and its agriculture equipments. Some examples of carbon and alloy steels are dual phase steel, micro alloy steels, and nano alloy steels. The next is the stainless steels. They're characterized by their corrosion resistance, high strength and ductility, and it has a high chromium content. So stainless as a film of chromium oxide protects the metal from the corrosion. So these are some of the typical applications of annealed stainless steel. So screw machine products, shafts, valves, bolts, bushings and nuts, aircraft fittings, rivets, screws, studs. Then chemical and food processing equipments, then cryogenic vessels, then high corrosion resistance and high grip strength chemical and pulp handling equipments, photographic equipments, then machine parts, pumps, shafts, bolts, bushings, pole clutch, hardwares, jet engine parts, machineries, screws, valves, then aircraft fittings, bolts, nuts, fire extinguisher inserts, rivets, and screws. So these are the applications of annealed stainless steel because of their good mechanical properties. Then types of the stainless steel: austenitic stainless steel, ferritic stainless steel, martensitic stainless steel, precipitation hardening pH steel, and duplex structure steels. Next is basic type of tool and die steel. So the high speed steel, AISI designation is molybdenum base and tungsten base. Second is hot work steel, that is chromium base, tungsten base, and molybdenum base. H1 to H19, H20 to H39, and H40 to H59. Then cold work D, that is high carbon, high chromium steel. A series, medium alloy and air hardening steel. Then shock resistance to steel is a O, that is oil hardening, and yes. The next is a mode steel, which is P1 to P19 series, low carbon, P20 to P39 others, and special purpose is a low alloy, and F is the carbon tungsten steel. Then water hardening steel, designated by the W. So these are the basic types of tool and die steels. Thank you for watching the topic cast iron type of steel.